Alright, we're performing a chromotography today, and it's the most widely used analytical process. It's used to separate and ID components of a dye. And the process in which a chemical mixture is carried by a liquid or gas is separated into components is a result of differential distribution of the solutes as they flow around or over the stationary liquid or solid phase. So now I'm going to perform dots of all the dyes. And you have to make sure they're small, because there's no need for a bigger one.
Make sure to get a full frame of you first, so that they... You ready? Yeah. All right. Just make sure to go.
Just take it. Yeah. Cheese. Does that have to be straight up or just flop it over there?
I mean, some angle, whatever.
Okay.
What do I do now? We wait. Let's see. Yeah.
You got saran wrap?
I've got like 3 other pairs. Sad for a second because I thought those were real. No, they were like $2. It's all good. Don't worry about it.
Wait. No.
I'm going to measure the RF factor. Measure from the line to the center of the dot. So I got about 2.4. Put it over this, and after you do it on the calculator, I get this number as the RF factor. This is the reference guide to spotting. Make sure when you spot, you make them very small because the spots are taken at a microscopic level. This is where the solvent line stopped, and this is an example of where the dot ended. So you put where the dot ended over the solvent line, and you end up getting this number, which is the RF factor. I think we rearranged.
No.
I'm going to take the measurement that the dye traveled on the TLC paper, and it traveled 4.7 centimeters. So I'm going to record that here, divide it by the total distance that the solvent traveled, which was 5.4 centimeters, and the answer is 0.870 would be our number.
All right, I'm going to take the measurements of the first spot. And it's 3.6. You're going to come over here and divide it by the solvent line. Yeah, the solvent travel, solvent line. That's 4.8. It gives me a 0.75 value.
Alright, good.
Each solvent we use to have a different polarity, therefore that explains the reason why each card that was made with the TLC card had a different movement of dye due to the different polarity reacting with the card.
Okay, the mobile phase is the solvent moving up the card. The stationary phase is the card itself. And the way to judge the polarities of the dye is to, the further it moves up on the card, the higher its polarity.